Hello and welcome to this third and final episode of our ongoing series of Mixtral versus LLaMA 2. If you remember from our previous episodes, we were using these two great language models to create summaries of YouTube video transcripts. These are videos on nature taken from the TED channel. And we could already explore how these models were capable of producing very nice looking summaries. Now we're going to delve deeper into evaluating the qualities of these summaries. I have put together this notebook and we're going to explore a couple of common metrics to evaluate the qualities of language models. First, we've got ROUGE, which is a very well-known metric which measures the number of overlapping textual units, engrams, between the summary and the reference. Basically, we're going to take two blocks of text and we're going to compare the overlap of lexical units. The more overlap, we're going to understand that it's a better representation of that content for the purpose of summarization. So that we get an understanding and an intuition of what this metric is about, I have put together an example, a minimal example. This is a text extracted from the Wikipedia about automatic summarization. And it goes, automatic summarization is a process of shortening a set of data computationally to create a subset, a summary, that represents the most important or relevant information within the original content. Artificial intelligence algorithms are commonly developed and employed to achieve this, specialized for different types of data. This is the description directly taken from the Wikipedia. If we would like to summarize that, there's not a single unique answer. It's not like 2 plus 2 is going to be 4. There's going to be multiple ways we could do that summary, and we need to find a way to rank those different ways. Here I have suggested 3 different summaries. The first one goes, automatic summarization consists of turning longer input data into a shorter subset, keeping the most important parts. The second one goes, automatic summarization is the process of shortening data computationally into a subset of most relevant information. The third one goes, automatic summarization, computationally relevant artificial intelligence specialized data. So this is, an example that I put together for the purpose of highlighting a few aspects. All 3 of them are related to the original text, so they more or less belong in the same contextual space. The first one does more paraphrasing or rephrasing, so it is essentially correct, but it writes it in a different way. The second one is very faithful to the original language, but just shorter. And the third one takes word from the original text, but it's not cohesive. It's not actually grammatically correct even. So let's see how these 3 summaries rank with the ROUGE metric. We need to organize the data in a particular way to feed into the implementation of PyRouge. That's not important for the purpose of our discussion. What's important is that we can now have the metrics. And ROUGE has multiple metrics. We're focusing on so-called ROUGE L, which goes for the longest n-gram overlap that we can find. And between precision recall and F, we're picking F as the final metric. So just so you know, this is the metric we're picking for this discussion. And we can find that the highest score, and the actual score doesn't mean much in isolation, it's more the relationship between the different scores, which is going to give us the indication whether a summary is better than other or not. So in this particular case, the highest number is that for B. So this would say that the best summary of the 3 was B, which is, I think quite all right. B was correct, and using a lot of the language in the original text is very faithful, so I agree it might be just the best summary of the 3. Comparing though the score for the other two, they are very similar. In particular, the C is even slightly better than A. Here you can see one of the weaknesses of this kind of evaluation metrics, which is C is clearly not better or even comparable to A. C is picking a lot of the words from the original text, but it's not cohesive, it's not grammatically correct. I wouldn't say it's a particularly good summary. Whereas A, I think, does a pretty good job at capturing the original paragraph. It just does a bit of rephrasing in a different language. So, because these language models can paraphrase the information when making the summary, we don't want to penalize particularly a model which does a good summary but takes it into a different way of writing it. So let's explore some other metric. By the way, this problem here is typical from all the lexical metrics, which are based on some kind of lexical overlap. So we're going to consider now semantic overlap. As we just saw, lexical overlap metrics have some limitations, and now we have luckily other kinds of metrics which are based on semantic information. In this particular case, I'm focusing on BERTScore. BERTScore is an automatic evaluation metric described in this paper from 2020, and it essentially takes the embeddings from a BERT model and compares those embeddings, and that will give you a very good indication whether there is semantic overlap, which is a better indicator than lexical overlap. So let's take this tool and let's make it work for our purpose. One caveat is that, as the authors mention, the BERT and some other related models have a limitation of 510 tokens in the context that we can explore. And as we saw, our summaries are larger than that, and our reference texts even larger. So that's not going to work for our purposes. Luckily, there is another model, which is the XLNet model, which has been trained in a similar way, but which is, according to their authors, has excellent performance for language tasks involving long context. So that sounds exactly like what we need. Let's go ahead and create a BERTScore based on this XLNet large model. And we will be picking the embeddings from layer 7. How do I know that? Because I checked the author's recommendation page, which I recommend you do as well. So let's go ahead and create the BERTScore object. There you go. And let's run this basic example that we were just considering about the three summaries for the automatic summarization description from the Wikipedia. And we get these three numbers. Again, the higher the number, the better it is for the purpose of the summarization. By the way, a small side note, here we're comparing the reference text before the summary with the actual summary. In the literature, you will find very often that summaries are compared against a humanly created summary. So you compare summaries one against the other. In this particular case, because we don't have humanly created summaries for the 100 transcripts of the YouTube channel that we just showed, we're going to be using this metric in a slightly different way, which is we compare each of the summaries against the reference. And we're going to take that score as a metric to show which summary is preferred. So here we see that similarly to the ROUGE metric, the second one is the highest scoring, which seems about right. But here, unlike ROUGE, we see that the first is significantly better than the third and not so far apart from the second, which matches pretty much my own impression as human labeler, if you say, from these three summaries that we were contemplating. These three, all right? So it looks like we've got a much better scoring metric for our purpose. So let's go ahead and use this for transcript summaries. We have now established that BERTScore is a suitable metric for the purpose of comparing summaries from LLaMA 2 and Mixtral. So let's go ahead and run the comparisons. First, let's just load our generated summaries, which are available in the summaries folder and were created in the experiment we ran before. And let's pick some examples. In this case, let's focus on the first example. So this is the reference. This is the transcript from the first video. It's quite long, going into the details of the turtle evolution. This is the summary created by Mixtral, extracting curious facts. And this is the summary created by LLaMA 2, which in principle looks like both look quite good. But one of the two is going to be better according to our metric. So let's go ahead and find out which of the two is going to be better. First, let's examine how much we actually summarized. And the original text, like an approximate measure, is going to be around 600 words. And the summaries, Mixtral took it about 300 words, and LLaMA 2 about 200 words. And the first thing we notice is that we are producing a summary of about 1/2 or 1/3 of the original content. So the first goal, which was to summarize a longer text into a smaller piece, I think we can say we achieved that, but actually it didn't really follow what we asked. Because if you remember from our previous video, in our prompt, we were asking for 100 words or less. So one of the things we noticed is that none of the models was particularly good at sticking to that recommendation. And this is a running theme in the community, which is a lot of people use language models for purposes they are not particularly well suited. So everything related to formula computation or doing math, but not solving math problems, but math about the actual generation that you're doing, that might not work as you would expect because that's not the strength of the LLMs. Let's actually get those scores. We're focusing on the F1 scores, by the way. From this scorer, we can get the precision and recall, but similarly to what we did with the ROUGE metric, we're going to be focusing on the F metric instead, which takes into account both precision and recall. Here, both of them have similar marks, which is consistent with my first impression that both summaries look pretty much of the same quality. But in this particular case, Mixtral wins with a slightly larger metric for the BERTScore. Let's first check that we actually are considering the full text of the reference transcript. Remember that the authors warned that using BERT directly would only be considering up to the 510 first tokens, and we have larger, as you just saw, we have larger inputs here. So let's make sure that with Excel network, we're actually considering the whole of the text. How do we do that? We're going to add some extra content in the reference text, and actually I'm going to throw in a few words in another domain so that it has a different ranking inside the embedding space. It's going to belong in another subject area altogether. Computers, GPUs, and processors have nothing to do with turtles and evolution. So that's going to throw off, I hope, that measure. And in fact, we can see that the scores now are slightly lower, which is a good indication that we're actually considering the full length of the transcript, which is what we wanted. And we're coming to the end of this experiment. I know it's being a little bit heavy on the scientific side, but it's going to be worth it, believe me. And we're going to calculate now the winner by using this F score of the BERTScore metric for each of the summaries that we collected, 100 summaries of YouTube videos. So we calculate that for both Mixtral and LLaMA 2, and let's calculate the winner in each case. By the way, this is running in the GPU. And it took about 9 seconds to complete for 100 comparisons. Just for us to keep in mind, if we did that on the CPU, which you can, let's do it just for 10 summaries. And you saw it took in excess of 20 seconds for just 10 summaries. So we are in the ballpark of 25 speed up by computing these evaluations with GPU acceleration. So if you're doing a lot of these comparisons, even if you're not using LLMs, you might still benefit from GPU acceleration. And now let's plot the winner. And these are the results. This is the win rate, meaning from the 100 summaries, in 60 occasions, Mixtral was preferred, and in 40 occasions, LLaMA 2 was preferred. This is interesting because it's not widely different. So it kind of matches my initial observation that both models looked pretty capable of performing this task. If you really need some data to back your decisions, it means that for this particular use case, you would go with Mixtral. Remember, we haven't done extensive prompt engineering, we haven't done fine-tuning, so there are other axes that we could play with to improve our summaries. But in this setup that we explored here, Mixtral wins 60 times over 40 LLaMA 2, considering the BERTScore, which takes into account the semantic overlap. We have now stored our winning summaries into a separate file, and this is now available in the repository for your inspection. So you can open it in a spreadsheet software, and for each particular transcript, let's go ahead and pick this one. Why are sloths so slow? This is the original transcript. This is the Mixtral summary. This is the LLaMA 2 summary, and in this case, Mixtral won. So we would pick this one. If we were going to have a website or a downstream service where we use this result, then we could use this system to decide which result to use. And that's all for our series of LLaMA 2 versus Mixtral. I hope you enjoyed it. I hope you learned a few interesting bits. Let us know in the comments your impressions. And I only have to thank you for your attention and wishing to see you again in the next video. Until then, stay safe.